Problems 36 and 37 from chapter 26. A human being can be electrocuted if a current as small as 50 milliampere passes near the heart. An electrician working with the sweaty hands makes good contact with the two conductors he is holding, one in each hand. If his resistance is 2100 ohm, what might the fatal voltage be? In this question, we are going to find the answer for the voltage. So here, an electrician, his hand is wet because of the sweating, and he is holding two conductors, one in each hand. And the current in the conductor is 50 milliampere, and his resistance is 2100 ohms. By using the current value as well as with the resistance, we are going to find what should be the voltage. So for this, we have to use the basic equation which we studied in the theory, V, which is equal to I multiplied by R. V stands for voltage, I is the current, and R is the resistance. So first of all, let's rewrite the given first. So what is given in the question? The current, which is equal to 50 milliampere. I have to write the value in terms of ampere. Milli takes the value of 10 power minus 3 ampere, and the resistance value is R, which is equal to 2100 ohm. Now we have to use the equation voltage, which is equal to the current multiplied by resistance. So here the current takes the value of 50 multiplied by 10 power minus 3 ampere multiplied with the resistance 2100 ohms. So here I got the answer for the voltage as 105 voltage. So this is the answer for this question. Now the second question is the question number 37. So here a 120 volt potential difference is applied to a space heater that dissipates 1500 watt during operation. First question, what is its resistance during operation? And the second question is, at what rate do electrons flow through any cross section of the heater elements? So in this question, the voltage, the potential difference value is given as 120 volt, and the power of the element, the space heater element, is given as 1500 watt. By using this potential difference as well as the watt, we are going to find what should be the value of the resistance. And the second part, we are going to find the answer for the current over charge. How much of current divided over charge gives the answer for the second question. So first of all, let's rewrite the given first. Potential difference V, which is equal to 120 volt, and the power P, which is equal to 1500 watt. So in the first question, if you want to find the answer for the resistance, in theory, we studied three equations for calculating the power. So what are they? Power P, which is equal to the current multiplied by the potential, power P, which is equal to current square multiplied by resistance, and then the third equation is power P, which is equal to potential difference square over the resistance. Here we can't use the first two equations because the current information is not given in the question. So I am going to use the third equation. By using the third equation, I am going to find the answer for the first question. So I am going to get the answer for the first question. So here I am going to use this equation, power P, which is equal to V square over R. I have to rearrange this equation in terms of resistance. If you rearrange this equation in terms of resistance, this equation is modified as resistance R, which is equal to potential difference square over power. And here we have the answer for the potential difference as well as the power. I am going to substitute this value in this equation. If you substitute this value in this equation, we will get the answer for the first question. So here the potential difference is 120 volt, which is square, so whole square, over the power value is 1500 watt. So here I got the answer for the resistance, which is equal to 9.6 ohm. So this is the answer for the first question. In the second question, we are going to find the answer for the current over charge, because the rate do electrons flow through any cross section of the heated elements. That means the current over charge value we are going to find. So this question you can find the answer in different way. So here I am going to show you two methods. In the first method, I am going to use the equation. So let's rewrite the question is second one. So here I am going to use the equation of the power in terms of the current multiplied by potential, the potential difference. I have to rearrange this equation in terms of current. So current, which is equal to the power over voltage, right? And here we know I'm going to divide this equation, both the left hand side and the right hand side, by using charge. So in the left hand side also, so divide both sides by Q. Q here is the charge value. So by that, this equation will become I over Q, which is equal to the power over Q multiplied by V. So now we have all the values, right? So power value is given as 1500, and the charge value we know 1.6 multiplied 10 power minus 90, and also we have the potential difference value is 120 volt. By using this, you can easily find the answer very directly. So let's substitute the value here. The power value is 1500 over the charge. The value of the charge is 1.6 multiplied 10 power minus 19 multiply with the potential difference 120. And here I got the answer for the charge, for the current over the charge, which is equal to 7.81 multiply 10 power 19, and the unit is 1 over second, because the current over charge is nothing but 1 over time. So this is the answer for the second question. You can find the answer in another way also. So I'm just work out the another method here. So here in the second alternate method, you can just use this method also. So here what I'm going to do, I'm going to use the equation of the current. So we studied in the theory, current which is charge, which is equal to the current multiplied by time. So I'm going to rearrange this equation in terms of current over charge. So the current over charge, which is equal to 1 over time, right? So here what I'm going to do, I'm going to use the basic equation for the power. So what is that equation? Power P, which is equal to the energy over time, right? And here what is this energy? The energy is nothing but, in the theory we studied, energy which is equal to the charge multiplied by voltage over time. So what I'm going to do, I'm going to use this. Better we can rearrange this equation in terms of time, and after that I'm going to take this value, I'm going to substitute here. If you rearrange this equation in terms of time, so time which is equal to charge multiplied by potential difference over power, I am going to take this value and substitute here. If you substitute, what will happen? I over Q, which is equal to, in this place I'm going to substitute this equation, Q multiplied by V over P, and this P will go to the top, right? So if you rearrange this equation is modified as current over charge, which is equal to power over charge multiplied by voltage, and power value we have as 1500 watt, and the charge, the value of the charge is 1.6 multiply 10 power minus 19, and the voltage value here is 120. So here also we will get the same answer. So the answer for this part, 1 over Q, which is equal to 7.81 multiply 10 power 19, and the unit is 1 over second. So why it is 1 over second? Because here you have to see the equation, because the current over charge, which is equal to 1 over time, so the time unit is second. So the answer for the last part is, the unit is 1 over second. So you can find this answer for the B part in two different ways. Okay, so both way will give the same answer. So this is the answer for the second part. That's it. Thank you.